And hello, everyone. It's strange to be speaking into the void, but it's great to see the names and so many familiar ones. I wish we could all be together in one of the sunny rooms overlooking the Fox River in the Warch Campus Center, watching the eagles swooping down and catching fish. But the silver lining, of course, is that in this mode, more of you can join us from wherever you are and visit campus virtually. So wherever you're coming from today, in your mind's eye, travel with me a little upstream from campus to Lake Winnebago. And that's where we're going to start our meditation on time. For a few weeks each February, small towns pop up like brigadoons on the ice of Lake Winnebago, the largest inland water body in Wisconsin. Winnebago is a vestige of the much larger glacial lake Oshkosh that formed from ponded meltwater late in the Ice Age and left behind heavy clay sediment that's the bane of gardeners in our area. Lake Winnebago is shallow and often alarmingly green in the summer as a result of runoff from lawns and farms, but it still supports a healthy population of lake sturgeon. Each year, before they head into upstream tributaries to spawn, the sturgeon in Lake Winnebago congregate in a few areas, and the temporary towns start to appear on the ice, mirroring the fish communities below. Sturgeon are large fish. The record setter for the area was 240 pounds, bigger, as the local paper pointed out, than a popular Packers linebacker. They have lifespans longer than those of humans, and their lineage has been around since the early Cretaceous. They're caught not with delicate hooks and lines dropped through narrow auger holes in the ice, but with trident-like spears plunged into large rectangular openings sawn in the lake. If spearing sounds brutal, it is at least a fair match between humans and fish. Spearers wait for days or in dark shanties illuminated only by the otherworldly glow of secondhand sunlight that shines through the ice and reflects off the bottom of the lake. If a sturgeon happens to swim by, it is a feat of athleticism to plunge the spear with sufficient force at precisely the right moment to strike it, and then to wrestle it out of the frigid water. Some people have sat hunched in sturgeon shacks for 30 seasons without getting a single fish. Some fish have been swimming in the lake for more than a century without being caught. As early as the 19-teens, there was concern about the declining sturgeon population in Lake Winnebago and connected waters. Both the flesh and the roe of sturgeon fetched high prices, and year after year, commercial fishing operations caught as many fish as possible. In the winter of 1953, when almost 3,000 fish were taken, the public awoke to the possibility that the sturgeon could soon be harvested to extinction. Sturgeon spearers and the Wisconsin Department of Natural Resources began to work together to monitor the population and set catch limits. During the spring spawning season, citizen volunteers, the Sturgeon Patrol, stand guard along tributary rivers where the females come halfway out of the water to lay their eggs on shallowly submerged rocks, and males follow to fertilize them. DNR biologists keep a close watch on the winter sturgeon harvest. As soon as the quota for a given year is reached, the season ends, sometimes just hours after it opened, and spearers, knowing that this protects sturgeon stock for the future, respect the system. Weigh stations are set up on the shore at the spots where the ice roads to the shanty towns begin. Each fish is sexed and weighed. Its age is estimated by cutting a slice off its dorsal fin, which grows bands like tree rings. That one's older than great grandma. This one hatched when Coolidge was president. The weigh station itself is an ephemeral village where people of all ages gather to see the giant fish pulled from this parallel primeval world that exists so close by but can only be glimpsed for a few weeks each winter. The French philosopher Bruno Latour has argued that a defining characteristic of modern society is a peculiar propensity for understanding time that passes as if it were abolishing the past behind it. We think that our worldview represents an epistemic rupture so radical that nothing of the past survives, and that our technologies lift us above the oppression of natural history that for so long defined the human experience. As permanent exiles from the past, we have mixed emotions about it. We allow ourselves moments of nostalgia, but scold people for living in the past. The prevailing consensus is that the past must, in fact, be abolished to make way for better things. We caution each other about becoming Luddites, slipping backwards, returning to the Dark Ages. But stranded on the island of now, we are lonely. When I see people crowded together in the cold each year to see big, old, ugly fish being weighed, I sense a very unmodern yearning to connect with the past. And I suspect that our self-imposed exile from it is the source of many ills. Environmental malefactions and existential malaise are arguably both rooted in a distorted sense of humanity's place in the history of the natural world. We need a new relationship with time, a habit of mind that could be called timefulness, an awareness of the natural history that envelops us, a sense that we too live in geologic time and are part of a continuum from the planet's past into its future. Timefulness is a deliberate counterpoint to timelessness, an unattainable, sterile, and even dangerous aspiration. But we live in a time illiterate society. We'd be shocked if an educated adult had no idea where the continents were on a global map, yet don't seem bothered by the fact that few average people have any sense of the geography of the planet's past, the durations of the chapters of Earth's history, the rates of planetary processes, or the intrinsic timescales of natural phenomena like climate change or groundwater flow. Even though we will spend our entire lives here, too many Earthlings behave like bad tourists on the planet, enjoying its amenities and ransacking its bounty without ever having noticed that it has its own ancient language and customs. The science of geology has produced many commodities for humankind: coal, oil, gas, metals, groundwater, not admittedly always in environmentally friendly ways, but it could be argued that the greatest product geology has created is a detailed map of deep time. The geologic timescale is truly one of the great intellectual achievements of humankind, but underappreciated since it wasn't the work of a single genius, but rather legions of geologists, paleontologists, geochronologists from all over the world over the past 2 centuries. Contemplating deep time makes people uncomfortable for a wide range of reasons, from psychological to economic. In our culture, time denial, or what we might call chronophobia, is rampant and comes in many varieties arising from different sources. If we seek to dispel time illiteracy, it's important that we understand its origins. The most obvious and vocal opponents of deep time are, of course, young Earth creationists. But it's worth noting that 200 years ago, geology and theology were not at odds. In fact, the scientific discovery of deep time, to use John McPhee's evocative phrase, was actually motivated by religious belief. The beginning of modern geology as a discipline is usually traced to a Scotsman, James Hutton, who was a physician, gentleman farmer, naturalist, and polymath on the fringes of the Edinburgh Enlightenment in the late 1700s. He often drank and dined with the likes of the philosopher David Hume, the inventor James Watt, the economist Adam Smith, and apparently Ben Franklin even was a visitor to Hutton's home once. As a landowner, Hutton was concerned for economic reasons that the very large amount of soil he could see was being washed away from his coastal Scottish farm each year. But as a religious person, a deist, like many Enlightenment thinkers, he was also troubled spiritually by the idea that God would simply allow the earth to be worn steadily away by erosion, that at some time in the future, all of the continents would be eroded to sea level and the earth would be uninhabitable. So his writings suggest that he was actively looking for evidence of some compensatory process of rejuvenation. And he found it late in his life at this rocky promontory off the east coast of Scotland. It's called Sicker Point. And I hope you can see my cursor here so that you can read these rocks with me. What Hutton recognized at this site were 2 sequences of rocks: an older sequence, a sedimentary sequence that was laid down as horizontal layers at one time, but now is vertical, overlain across an irregular boundary with younger, also sedimentary rocks that are more nearly horizontal. And it was a huge, intuitive, inductive leap of understanding that made him realize that these older rocks represented the eroded remnants of a great mountain belt. And the contact between these 2 sequences of rocks represented the time it would have taken to erode that mountain belt to sea level. So he postulated from this single outcrop the idea that the earth indeed does have these processes of rejuvenation, erosion, in a cycle that's never ending. In his 1788 treatise, Theory of the Earth, published the year before he died, He famously wrote, "The result, therefore, of our present enquiry is that we find no vestige of a beginning and no prospect of an end." He saw, indeed, he inferred that the world was infinitely old and had an infinite future ahead of it. So Hutton gave us deep time, but wasn't particularly interested in the granular details of what happened when and in what sequence. Hutton's beautiful idea of an Earth that was infinitely old and continuously regenerating apparently captured the imagination in the way that space exploration does in our time. In the upper left here is a depiction from a British popular journal of Hutton's unconformity. You see the old rocks representing this ancient mountain belt, a kind of rubbly layer representing the eroded remnants, and then the new landscape formed, and then the modern landscape above. And this image and things like it were widely circulated in Britain and the US. About a generation after Hutton came geology's Newton, Charles Lyell, who wrote this treatise, Principles of Geology, in the 1830s, which was a bestseller in both the United States and the UK. In fact, it was so widely distributed that Mark Twain, in his autobiography, has a very funny passage describing a grizzled old riverboat captain who had a copy of Principles of Geology in his cabin on the river. So it seems to me that this huge popularity of Lyell's book and of Hutton's ideas on both sides of the Atlantic, the idea of an old Earth apparently wasn't perceived as a dangerous threat to religious belief systems at that time. It wasn't until paleontology began to uncover evidence of extinct creatures and vanished ecosystems, and then, of course, when Darwin suggested how organisms, including humans, could have evolved through the non-directed process of natural selection, that the church began to see geology as an adversary. I want to acknowledge that many other cultures around the world probably did not have the same aversion to deep time and the idea of biological evolution that the Judeo-Christian West has had, but I focus here on the European tradition because it is in fact where modern geology and the calibration of deep time got its start. Anyway, at this point in the early 21st century, geology has been contending with creationists and young earthers for more than 150 years. And it's easy to be derisive about young earth thinking, but I do empathize with people who are truly struggling to reconcile their religious beliefs with scientific understanding. I occasionally have students who are in this position, and I offer them a variation on an argument made by the philosopher René Descartes in his Meditations on the Nature of Reality. It goes like this. Well, early in a geology course, you begin to understand that rocks are not nouns, but verbs, records of processes. For example, this outcrop near Baraboo on the left is a rippled sandstone bed that is vertical. The ripples are a memory of when the rock was laid down in some sort of shallow marine environment. And the fact that the beds are vertical is, just as at Sicker Point, a record of mountain building. So we have water flowing and mountains growing here. So I ask students to consider which is more heretical: to accept the idea of an old and evolving Earth set in motion 4.5 billion years ago, whose internally consistent history, a remarkable and awe-inspiring saga, has been worked out little by little over the past 200 years by people from many cultures, or a deceitful creator who has planted false clues about the planet's past in every nook and cranny, from fossil beds to zircon crystals we may one day analyze isotopically, just to mislead us deliberately. And students have to decide for themselves. But I have no patience for the aggressive disinformation, the awful mashup of biblical literalism and alleged science that is posted online by the Institute for Creation Research and turned into lucrative business ventures at places like the Creation Museum in Kentucky. To those who actively distort scientific facts and fog the brains of young earthlings, not to be confused with young earthers, I would say, okay, live with the implications of your worldview. You shouldn't have access to fossil fuels, since the gas in your car was found by geologists with an understanding of the stratigraphic record. Likewise, modern medicine is off limits, since much is based on testing on mice, which only makes sense if you understand that they are our evolutionary kin. Apocalypticism is a dangerous offshoot of religiously motivated time denial, in which not only the geologic past, but also the future are foreshortened. If you think there is no future, then there's no need to conserve or be concerned with climate change. In fact, not using up resources is paradoxically wasteful. But again, young earthers are at least completely open about their aversion to time. More insidious forms of time denial are woven into the very fabric of our culture. Our natural existential dread of aging and death has become entangled with vanity through capitalistic messaging in a society obsessed with youth. As a result, we fear and loathe our timiness, making us afraid of time as big business. Time denial is a multi-billion-dollar industry. At least this particular product seems to be forthright about being completely detached from reality. Have you noticed these days, we more often refer to ourselves as consumers rather than citizens, and that doesn't seem to bother anyone? Citizen implies living somewhere over time in proximity to others with the attendant give and take that requires. Consumer suggests only taking, as if our sole purpose were to devour everything in sight now, in the manner of locusts descending on a field of grain with no thought of the consequences for the future. And we are as insatiable as locusts for novelty, the newest smartphone, the just released app, the meme of the moment. We don't notice how quickly all of these age, become old, tired, so 5 minutes ago, because the next ones arrive to take their place before we have the chance to dwell on that, allowing us to remain pleasantly distracted in an never-ending now. The narcissistic preoccupation with our own creations has led to a mass delusion that we've outgrown the natural world. In this country in particular, there's a widely accepted notion, a virtual credo, that free markets represent an almost sacred natural state, that anything that fetters them, including protections for nature itself, which provides the raw goods for those markets, is unnatural. And while we may scoff at apocalyptic thinking, the opposite view that we can carry on forever at ever increasing levels of resource consumption is equally deluded. But it must be acknowledged that science itself is culpable for other strains of time denial. In the hierarchy of sciences, it's telling that the pure, that is timeless, eternal ones, physics, but also chemistry, are most esteemed. Biology and geology, which reek of time and history, are by implication impure. There's no Nobel Prize in geology, though there is one in economics. And I respect the accomplishments of other sciences. Geology, of course, is a highly interdisciplinary field that necessarily draws on the principles and methods of physics, chemistry, and biology. But many environmental problems we face today are the result of the failure in the early to mid 20th century to anticipate how new technologies, the internal combustion engine, chemical fertilizers, antibiotics, plastics, would interact over time with complex, evolving natural systems. Excuse me, my phone is ringing. The scientists and engineers behind these innovations could have used a bit of geologic thinking, some timefulness. An unfortunate reality is that the unintended consequences of our technologies will almost always outlive our intentional implementation of them. To think geologically is not as much about time itself as the power of time to inexorably alter, entangle, magnify, ramify, complicate, and otherwise transmogrify. But geology too, as a discipline, has been at fault for failing to put human and planetary timescales in proper perspective. First, for a variety of reasons, geology is a late bloomer. It's a little embarrassing that the laws of thermodynamics were worked out in the 19th century, the structure of the atom in the early 20th, but plate tectonics, the way the solid earth works, was not figured out until 1965. Some of the delay was technological. Earth was too close and too big to see clearly. But it was also partly due to the myopia and lack of imagination of the majority of geologists in the early to mid 20th century, who for various reasons were not able to see the Earth as a dynamic planet that was continuously reconfiguring itself. The relatively late maturation of the geologic sciences haunts us today. In the early 20th century, as high school science curricula were becoming standardized, geology was not yet a rigorous discipline. It lacked a coherent conceptual framework, and so it was left out. As a result, we have a generation of earthlings, including very educated and powerful people, and even many trained in other sciences, who have never had even the most basic introduction to the way the Earth works. But another ironic reason for public time illiteracy is that in some ways, we geologists have been too emphatic about the immense antiquity of the Earth and the slowness of geologic processes as a result of our constant vigilance against young earthers. I'm sure you're all familiar with the clock analogy for geologic time, that if the 4.5 billion year history of the Earth were a 24-hour day, we modern humans would have appeared at just the last fraction of a second before midnight. And although this is literally true, I think it's wrong-headed in several ways. First, it's alienating. It suggests we appeared out of nowhere and denies our deep roots in the evolutionary past. We modern humans in present form are relatively recent arrivals, but our ancestors have been here since the early morning hours. And it seems to absolve us for responsibility for our actions. How could anything we've done in that last fraction of a second matter to the Earth? Also, Earth is really not so sluggish. It has many tempos, moods, and modes, sometimes moving too fast for us to keep up with. And this is just a reminder that yesterday was the 10th anniversary of the giant Japanese earthquake and tsunami of 2011. There are also unfortunate asymmetries in the rates of Earth processes. Evolution is slow, but extinctions can be brutally sudden. Sliding into an ice age is generally gradual, but warming up is usually abrupt. Groundwater accumulates for centuries or millennia, but can be depleted in years. Geology is a strange hybrid of the pragmatic and the philosophical. It's about where to find oil and groundwater, how to protect people from natural hazards. But it's also about deep existential matters. Where do we come from? Why is the Earth the way it is? What factors favor stable, resilient ecosystems and societies? And it's as much about the future as the past. In 30 years of teaching and talking and writing about geology, I've tried to come up with ways to help people start thinking like geologists. And one apt metaphor for geologic thinking is a palimpsest manuscript. In medieval times, texts were written on parchment, a commodity that required a lot of labor to produce. So they were often used and reused many times, scraped and then re-inked. Always, though, vestiges of the older text would remain underneath the more recent text. Similarly, landscapes have their histories written all over them, scraped by erosion and overwritten many times. Once you become attuned to the earlier scribbles, it's impossible not to see them. I often feel, in fact, that I don't just live in Wisconsin, but in many Wisconsins. There are the forests still recovering from 19th century clearcutting, the Great Lakes and mighty rivers that governed ancient trade routes long before Europeans arrived, legacies themselves of immense ice slopes that flowed down from Canada. There are golden Cambrian sandstones marking the shores of long vanished seas, the banded iron formations, steel gray and blood red, recording oxygenation of the atmosphere. And of course, every place on Earth has similar stories, sprawling multi-generational sagas of stability and upheaval, seas rolling in and out, glaciers advancing and retreating, mountains rising and being erased by erosion. Understanding those histories is a bit like learning the etymology of a word or phrase. One has a rush of insight, as if a window has been opened onto earlier times. It's almost like remembering something long forgotten. It's important, I think, to acknowledge that people can feel diminished by geologic time, that humans are made insignificant by it, and I can understand that. But I think it helps to start developing some depth of field in thinking about time. I had a math teacher who was fond of saying, there are many sizes and shapes of infinity. Some things, like the Pleistocene, the Ice Age, happened just the other day. Others say the formation of Pangaea a while ago, and some, the origin of life, a long time back. It's also useful to adopt the Greek distinction between chronos, raw time, billions and billions of years, and kairos, which is time within a narrative. As one starts knowing Earth's history and the vast stretches of geologic time are filled with narratives, protagonists, and plot lines, it's no longer alienating. The characters become familiar, the themes resonant. Once we open a few volumes in the library of deep time, we can begin to recognize ourselves in the tales of earlier Earthlings. Indeed, I find the idea of a 7,000 or 8,000-year-old Earth with a short, shallow story positively terrifying, while the evidence for an old and resilient Earth and the enveloping presence of so many ancestors with great wisdom to share is, to me, deeply comforting. One of the most important lessons of the rock record is the centrality of balanced biogeochemical cycles to the long-term habitability of the Earth. The message is, be loopy, dance endlessly around in circles. That is, recycle. Other than a fine rain of comets, micrometeorites, and the occasional dinosaur-killing asteroid, Earth has not acquired any significant new mass since it formed 4.5 billion years ago. Yet the median age of continental surface rocks is about 500 million years. The oldest ocean crust is 170 million years. The oceans are refreshed every few millennia. And as Hutton noted, soil is constantly washed to the sea, but so far hasn't disappeared. That means that everything on the planet is incessantly recycled, reforged, and restocked. The water, air, soil, the very crust of the earth at vastly different rates via evaporation, precipitation, oxidation, reduction, subduction, metamorphism, melting, and crystallization are reused, reacted, and remade. Every process has an inverse operation, every flow a compensatory counterflow. It's like an elaborate contra dance happening across many different spatial and temporal scales, in which after many rounds, everybody ends up back where they started. In fact, this tendency for infinite repetition and reinvention is the single most important attribute that distinguishes Earth from its sister planets. It's not simply that Earth happened to be the right size and the right distance from the sun, but that it developed habits as a young planet that have kept its surface environment stable for most of the past 4 billion years. And life got involved in that circular logic very early on. But it's also sobering to note that all of the great mass extinction events of the geologic past have been linked with severe disruptions to the carbon and other biogeochemical cycles. Even the dinosaur extinction event, which of course is linked with the meteorite impact, was ultimately caused by the ensuing upheavals in the chemistry of the atmosphere and the oceans. And the bedrock story of the greatest mass extinction in Earth's history, the End-Permian cataclysm, tells how a thriving global biosphere was nearly dealt a mortal blow by the combined effects of abrupt volcanically induced greenhouse warming, ocean acidification, and widespread marine anoxia, a chillingly familiar scenario to Anthropocene listeners. Students sometimes ask me if I worry about the possibility of the Yellowstone caldera exploding in another supervolcano eruption. As a geologist, I know that could happen, but the probability is quite low in our lifetimes. But as someone who delves daily into the deeper rock record, I do lie awake at night worrying about the magnitude of our perturbations of global biogeochemical cycles. The growing dead zones in the oceans, in the Gulf of Mexico, Chesapeake Bay, and the Baltic Sea, for example, caused by a vast overabundance of nitrogen, mainly from fertilizer runoff, looks awfully similar to the story told by sulfurous black shales in the Permian extinction event. And of course, the big elephant or element in the room is carbon, namely our non-looping, uncompensated one-way injection of it as carbon dioxide into the atmosphere. Anthropogenic CO2 emissions now outpace those of volcanoes by a factor of more than 50. And an unjust fact about carbon emissions is that while one part of the world, the US and Western Europe in particular, has been responsible for a disproportionate share of the output over the past century, the whole world suffers the consequences. This is because the mixing time of the troposphere, the lower atmosphere, the time it takes for turbulent stirring by winds and weather to homogenize the air on a global scale is relatively short, about a year, compared with the residence time of carbon in the atmosphere, 100 years or more. If the mixing time were long compared with the residence time, then CO2 would hover close to the places where it was released, like garbage piling up when trash haulers strike, and that might motivate action to emit less. But because our individual emissions are not only invisible, but conveniently dispersed around the world, we have little incentive to curtail them. An especially tragic irony is that our CO2 emissions, by increasing ocean acidity, are also undermining formation of carbonate rocks by microorganisms like these coccolithophores. This is Earth's long-term carbon sequestration scheme, the process that has kept the planet from becoming a runaway greenhouse like Venus, but it is not able to keep up with our perturbations to the carbon cycle. In spite of the overwhelming evidence that we are biogeochemical outlaws, we'd rather wait for a silver bullet technological solution than do the hard work of changing our habits. In our culture, we tend to mistake technological prowess for wisdom. The people we call visionaries base their conceptions of the future on the notion that we should do everything in our power to circumvent the irksome constraints of the natural world, not appreciating that Earth is so much more powerful and more patient than we are and will always prevail in the end. The idea that Earth time just doesn't apply to us leads us to delusions that we can outsmart the complex system of biogeochemical cycles and, for example, magically solve our climate woes through climate engineering strategies like stratospheric sulfate injection, and expect that there won't be a powerful backlash of unintended consequences. Disrespect for time also seduces us into thinking that we could skip over all that inefficient millions of years of evolution stuff and just terraform ourselves another planet. Engineering the climate or terraforming Mars sound easy if you're completely unaware of the intrinsic timescales of geological and biological phenomena, the deep evolutionary pathways that gave rise to the world we live in, the intricately choreographed behind the scenes biogeochemical cycles, the housekeeping crew that make Earth habitable. Such ideas are beyond hubris, revealing not only a profound ignorance of the Earth, but also of human nature. What makes us think we could successfully change the rules that govern this or another planet when we haven't even learned to govern ourselves? Anthropologist Clifford Geertz famously defined culture as the constellation of stories that groups of humans tell themselves about their place and purpose in the world. In Western culture, with its Abrahamic underpinnings grafted to principles of social democracy and capitalism, the stories we share about who we are largely exclude the natural world. Nature is at most a passive backdrop, the scenery against which the real stories unfold, not a central protagonist in our narrative. Well, very soon now, the scenery is going to start directing the play. Long-term thinking and planning are absolutely essential to grappling with the intractable issues of our time: climate change, intergenerational poverty, and yet just when that is most acutely needed, our attention spans are shrinking. Our political and economic infrastructure has few mechanisms for sustained action over timescales needed to resolve our most intractable problems. Government is increasingly hamstrung by the 2-year congressional cycle, and corporate decision-making is yoked to good annual or even quarterly reports. As individuals, we hardly have time to look up from our beloved phones. Increasingly, the only institutions that can act on intergenerational timescales are authoritarian governments or foundations underwritten by the super wealthy. And while the actions of those organizations may be laudable, they're also fundamentally undemocratic. We need to redemocratize the future. When we peer into the geologic future, a paradox emerges. To some extent, we can see what lies in the far distance more clearly than what is in the foreground. The sun, as a G-type star, is about halfway through its life expectancy, and in 5 billion years or so, will enter its red giant phase, engulfing the Earth and the other inner planets. 3 billion years before that, however, the sun's increasing luminosity will lead to an extreme greenhouse effect from the vaporization of Earth's oceans. Once the planet's water is lost to space, the carbon silicate weathering system that's acted to sequester volcanic CO2 over time will shut down, creating an even more intense greenhouse state that will largely make surface conditions uninhabitable. For at least the next billion years or so, plate tectonics will continue to shuttle continents to new positions around the globe. The Atlantic Ocean will begin to close, and in about 250 million years, the Americas will be reunited with Europe and Asia in a new supercontinent that has already been given the name Pangaea Ultima. Meanwhile, rivers will have erased the Himalaya, Alps, and Rockies. In about 80,000 years, the Earth will reach the point in its orbital cycles where another ice age could happen, but this will depend on greenhouse gas concentrations, ocean circulation, the state of the biosphere, and many other variables. The next 1,000 years, the same amount of time that separates us from the Viking Age, are even harder to bring into focus. If human carbon emissions have not been sharply curbed and powerful positive feedbacks in the climate system are activated, the Earth could experience a replay of the Paleocene-Eocene thermal maximum 55 million years ago, when temperatures spiked 8 to 10 degrees and marine and land-based ecosystems were stressed to the point of collapse. Altered weather patterns, more ferocious storms, longer and deeper droughts in the next few centuries will probably stress world food production. Increasing proportions of government budgets will have to be channeled into crisis management. The balance of geopolitical power will shift depending on how nations fare in the new climate regime. But none of this is preordained. We have the power to rewrite a different saga for the coming millennium. Rather than lapse into existential despair that we won't be here in a billion years, let us claim at least the next few centuries. It is empowering, or at least therapeutic, in these dark times to imagine what a time-literate society might look like. In his last public interview, Kurt Vonnegut said, "I'll tell you, One thing that no cabinet has ever had is a secretary of the future. There are no plans at all for my grandchildren and great-grandchildren. So let us adopt Vonnegut's suggestion as our first proposal, a representative for the yet to be born to serve among the top advisors to the president. The Department of the Future would set in motion a realignment of priorities in all aspects of society. Resource conservation would again become a core value and patriotic virtue. Tax incentives and subsidies would be rebalanced to reward long-term stewardship over short-term exploitation. Putting a price on carbon might help us get a grip on our fossil fuel addiction, sober up, and let us prepare for natural disasters that will happen without our assistance, like the hundreds of large earthquakes that will happen in the next century, rather than expending resources on self-created climate catastrophes. Poverty and class-based disparity of opportunity would be recognized as problems with deep historical roots that cannot be solved without sustained commitment over commensurate timescales into the future. Public school teachers and others whose work represents an investment in the future would be paid well and held in high esteem. Geology would be fully integrated into science curricula, perhaps serving as a capstone course in which students would apply concepts of physics, chemistry, and biology to the immensely complex Earth system. More generally, schools would help develop children's knowledge of and appetite for history and natural history, instilling in them a deep instinct for their place in time and a keen curiosity to understand more. The dramatic narratives of the geologic past are perfectly suited to the human appetite for storytelling. With a solid understanding of how the planet works, those students would go on to become educated voters who would hold public officials accountable for wise governance of water, land, and air. Legislators, governors, mayors, and presidents who embrace the seventh generation principle would point proudly to what they're working toward and be re-elected by grateful constituents. I believe, perhaps naively, that if more people could experience a journey through time and see themselves as earthlings with a common past and shared destiny, it might spring us out of the polarized and entrenched ways of thinking about the world we've cornered ourselves into. As a geologist, I've worked with people from all over the world, from very different cultures and generations older and younger than mine. The strong human connections I've developed with them through our shared study of the Earth makes me optimistic that a geocentric view might help us overcome the animosities and barriers that divide us and get down to work on things that really matter. Collective awareness of Earth's story might save us from environmental hubris. Understanding how historical happenstance is written into each of our own personal lives might cause us to treat each other with more empathy. And a timeful habit of mind might even make us less neurotic about the fact of our own mortality by shifting our focus from the finite length of our lives to the rich anthology of experiences that a lifetime represents. While other senses may be dulled with age, the sense of time that can only be developed by experiencing it is heightened. Growing old requires one to shed the illusion that there is only one version of the world. As a technological society, I think we have an almost autistic relationship with the Earth. We are rigid in our habits, savants when it comes to certain narrow obsessions, but dysfunctional in many other regards because we wrongly view ourselves as alone in the cosmos. Believing that nature is something outside us, a mute and immutable thing external to us, we are unable to empathize or communicate with it. But we geologists understand that Earth is whispering in our ears all the time. In every stone, it offers an eternal truth or a good rule of thumb. In every leaf, a prototype power station. In every ecosystem, a model of good urban planning. In every watershed, an exemplar of a healthy economy. We need to reconceive ourselves as citizens of Earth, this still evolving tangle of old, recycled, sun-powered, and profoundly interdependent dancing parts. There's a teaching attributed to the 18th century Polish Hasidic rabbi Simcha Bunim that for me, a lapsed Scandinavian Lutheran, carries great wisdom. It says, one should always carry two slips of paper, one in your left pocket that reads, I am ashes and dust, and one in the right that says, the world was made for me. Both are true, and that's what rocks have been trying to tell us all along. Thank you.